Good day and welcome everyone to this video for PHIL151, otherwise known as logic, the art of reasoning. Alrighty, my name is Anko Peters, and for this video I will walk you through an example exercise on natural deduction, because it might be a bit tricky. I recommend that you have the inference rules for natural deduction handy while you watch this video and that you write along. So the deduction rules would be these. You can find them on Moodle. So yeah, look them up and let's get started. So natural deduction is applied on arguments that are valid, but you want to prove that they are actually valid. So let's start with a formal argument. So I'll give you four premises. The first one is if not P, then not Q. That's the first one. Then if not Q, not R. And if not R, then not S. I think you can see a pattern here. And the fourth premise is not P. So we have three conditional statements, and the conclusion will be not S. So let's take a moment and look at this, or the structure of this argument, right? Because before we dive into things, it's good to think about what we're doing. So you can see three conditional statements and one P, and the conclusion is not S. So you can see the not S is found in the third conditional, and the not P is found in the first conditional. So hopefully by this time you'll be thinking, all right, what if we apply not P to, or we take not P and we also take the first conditional. Remember the structure of having a conditional statement and this part, the first part of the conditional statement, and allowing you to conclude the second part. This structure is called modus ponens. So usually we write it like this: if we have P, or if P then Q, and we also have P, then we're allowed to conclude Q. So we have something like it here. We have the negation of P, and we have, if we have the negation of P, then not Q. So probably we can deduce not Q from this, and then maybe feed not Q into this statement, and then feed the conclusion of the second conditional, not R, into the third one, and then conclude not S. Alright, so I'm getting a little bit ahead of myself, but hopefully you can see that this structure makes sense, this strategy. So how can we do this formally? How can we prove that this argument is valid? Well, we start with writing down the premises on separate lines. So if not P, then not Q. This is an assumption in our argument. On the second line, we write if not Q, then not R. It's a second assumption in our argument. And then we write for the third line, if not R, then not S. It's another assumption. And then on line 4, we write the final and last premise. That would be not P. Okay, and then somewhere at the bottom we will have our conclusion, hopefully, if we get there, but I'm confident that we will. Don't forget to separate those with a line. So we don't know exactly yet what's going to happen here in between, but it's always good to keep in mind your goal at the moment. What are you trying to get at with this argument? Okay, so like I said, let's take another look at the premises here, and let's not forget that this is also an assumption. So we have a few conditional statements and we have a negation. Let's ignore the negation for now and just look at the conditional statements. So we have four logical connectives in general in logic. I mean, there's more, but there's four that we use. We have the negation, the disjunction, the conjunction, and the conditional statement. So if you look at your cheat sheet, you'll see that for each rule there is both an introduction and an elimination. So what the introduction does is, as you might have guessed, it introduces a logical connective. but here we actually want to get rid of the conditional statement, the arrow. So if you look at your cheat sheet, the elimination rule for conditional statements says, well, if you have a conditional statement and you have the first part of the conditional statement, what we call the antecedent, then you're allowed to conclude that you have the second part, the consequent. So it will look very familiar because that's the same structure as the modus ponens rule. So modus ponens. Anyway, turns out we have both of these ingredients. So we have the conditional statement, we have the first part, the antecedent. So let's just apply the conditional elimination rule. So what does this get us? Well, it gets us not Q. Hurrah. And we have done this by applying to lines 1 and 4. So this one and that one. The elimination of the conditional. So we've now concluded that we have not R. Okay, that's good, but we need to get it not S. So we're not there yet, but it turns out we have another conditional where we now also have the antecedent part of. So for the next line, we'll just do the same thing we did before. We'll be eliminating a conditional statement and conclude that we have not R. So, because remember, if you have the conditional and the antecedent, you can conclude the consequent. So basically we're just repeating what we did now, but with different lines, namely now we're looking at lines 2, that one, and 5, that one, and we eliminate the conditional statement. Alright, almost there. So now we have not R, and you can probably guess what happens next. For the next line, we'll be eliminating this conditional and conclude not S. But wait, that's the thing we were trying to prove here. So maybe it doesn't look as nice, but let's put the line 7 here, because for we can get not S by eliminating from lines 3 and 6 another conditional statement. And now we're done. We have taken the premises, these, and we have proven that from these premises you can draw this conclusion. Therefore, this argument is valid, or as we sometimes say in logic, Q, E, D, quod erat demonstrandum. It's the thing that we wanted to prove. So hopefully you found this video helpful, and good luck with the exercises.